Hello guys, it's Mr. Burns again. Welcome to your second lesson of your National 5 Chemistry. Today we're going to be focusing on the products of combustion. Last time we looked at fuels and fossil fuels and where they came from. So what we're going to look at today is, well, we take that fuel, we're going to burn it, aren't we? That's the only way we're going to get the energy out of that fuel. So what happens when we burn it and what do we get out? Okay. Our learning intention and success criteria should be fairly familiar to most of us. It's stuff that we've covered in S3 to a greater or lesser extent. Understand what is formed when a fuel burns. State the name of two different types of combustion conditions. State the products of combustion for the two conditions. Describe how to test each of the products of combustion. Okay, and our success criteria will be, you'll be able to describe how to test for the different products of combustion. There's a few scientific tests that we can carry out, an experiment that we can carry out, and you should be able to explain what each test result means. Okay? But first of all, what do we mean by product? Okay, because in science and in chemistry, the word product might mean something different to what it means in everyday life. So take a wee minute, pause the video, and think about what the word product means. Okay, hope you did that. Let's see if you were right. In any chemical reaction, there's always two things formed. Or there are always two things, sorry. You have the things that you start off with, the reactants, okay? These are always the things that you have at the beginning of any reaction. If you think about a reactant as being baking a cake, your reactant would be your ingredients, okay? Your flour, your eggs, your milk, your sugar. What we get out is our products, the new thing that's formed. Now, in our example there, the product would be the cake. There is always a product formed. There's always a new thing that's formed in any chemical reaction. If there's nothing new formed, then it's not a chemical reaction. In fact, that's one of the signs of a chemical reaction, that something new is always formed. Now, we don't always, or we can't always see that thing. If it's a colourless, odourless gas, for example, we can't always see it, but it will be there. Okay. I'm going to put up just now a word equation. Okay. A word equation is a chemical equation that's written out basically using words instead of chemical symbols. Okay, we'll move on and talk about chemical symbols and how we write them in Unit 1. This is a word equation because it's a chemical equation. We can see that because of the plus signs and the arrows, but it's using words. Okay. My task for you just now is have a little look and tell me or write down what the reactants are and what the products are. You can pause the video just now and do that. Okay, I am going to move on. I hope you got this right. But if our reactants are the things we start with, then our reactants are over here. And if our products are the new things that are formed, then our products are over here. Okay. In any chemical equation like this, the things on the left-hand side are the reactants, a little spelling error there, and the things on the right-hand side of the arrow, they're our products. That's something that's very important that you need to remember, that you will get used to doing that, because as we write more and more chemical equations, it will become like second nature to you. Now, if we have a look at this equation, you can see that we've got butane. Butane is a hydrocarbon, it's a fuel, and it's reacting with oxygen. Now what that means is that it's a combustion reaction. If you've got a fuel reacting with oxygen, it's a combustion reaction. And what we're getting out are products. And we'll look at these products in a wee minute. I just want you to get into the habit of, if you see something reacting with oxygen, the chances are it's a combustion reaction. And particularly if that thing is a hydrocarbon, it's going to definitely be a combustion reaction. However, there are two different types of combustion. The first type is when we have lots and lots of oxygen present. We know from our fire triangle that apart from the fuel and heat, the one thing that a fire needs is oxygen. Now, if there's lots of oxygen present, then all of the fuel will burn and it will combust and it will react to form products. And this is called complete combustion. So complete combustion is when a hydrocarbon burns in a plentiful supply of oxygen. In other words, there's lots and the whole fuel can react. And when that happens, you get two products formed. You get carbon dioxide and you get water. And if we have a look back at the last slide, you will see that's exactly what I had here. So I assumed complete combustion when I wrote this, and I said that I was getting carbon dioxide and water out. Okay? But what happens if, for whatever reason, we've not got an awful lot of oxygen present? Well, we're going to get different products formed. Because what's going to happen is, if there's not an awful lot of oxygen, then not all of the fuel is going to react. You're not going to get a lot of the fuel turning into these products, and in fact you'll get what we call incomplete combustion. So when a hydrocarbon burns in a poor supply of oxygen, remember there still has to be oxygen there, otherwise it won't work at all. But if there's a poor supply, then you get incomplete combustion. And in incomplete combustion, you get two products. You get unburnt carbon, that's black soot, okay? You can see it in that picture there with that fire. That's an example. You can tell that's incomplete combustion because there's an awful lot of black sooty smoke coming off there. That's just your unburnt carbon. Remember, a hydrocarbon contains hydrogen and carbon only. So what's happening is our carbon hasn't got enough oxygen to react with, and so it's just coming off as carbon. And that's really black sooty stuff. The carbon that does react with oxygen, well, there isn't an awful lot of that oxygen kicking about. So rather than forming carbon dioxide, its chemical formula is CO2. Now what that tells me is that there are two oxygens bonded to one carbon. If there isn't enough oxygen, then what you're going to get is carbon monoxide, CO. One carbon bonded to one oxygen. Okay? I would rather have CO2 than CO. And the reason for that is that carbon monoxide, this stuff here, is very toxic. It's called the silent killer. You will have carbon monoxide alarms in your house, because if your boiler starts to break down, starts to not work, it can release this gas, carbon monoxide. You can't see it, you can't smell it, but you can die if there is too much of it being ingested, because what can happen is that the carbon monoxide will replace the oxygen in your blood. Okay, you cannot live without oxygen in your blood, and slowly it will start to suffocate you and you will die. So it's a very dangerous gas. Carbon dioxide, from our last lesson, you'll know that carbon dioxide is a greenhouse gas, We don't want to be giving out a lot of greenhouse gases because they cause global warming. But I would rather have carbon dioxide given off than carbon monoxide, because carbon dioxide won't kill you. Okay, I would rather not have either, which is why we have to look at clean energy, and that's something we'll look at a little bit later on. So, two different types of combustion. Complete combustion is when we've got a lot of oxygen and we get carbon dioxide and we get water out. Incomplete combustion is where we've not got a lot of oxygen, and so we get this unburnt carbon, this black soot, and carbon monoxide, this very dangerous poisonous gas. How do we test for that though? How do we know? Well, hopefully it should make sense to you. If you've got hydrocarbon, which contains only carbon and hydrogen, and you're reacting that with oxygen, then the only things that can come off, the only products that you can form, are elements or compounds that have a combination of these three elements in them. In other words, well, you can get that black sooty unburnt carbon from your carbon. You might get hydrogen gas given off. You might get oxygen gas given off. That might be an option. Or you could get a combination. Now, if we combine our carbon and hydrogen, well, we're back to our hydrocarbon. If we combine carbon and oxygen, then that's going to give us our carbon monoxide or carbon dioxide. And if we combine our hydrogen and oxygen, well, that's going to give us water, H2O. But we need a test to prove that. So, what we've got here is we've got a test. You will have seen this in S3. The tea light candle is our fuel, okay, and the gas is going to be given off. We've got a pump at the other side over here, okay. Oh, sorry guys. Pump at this side, and that's going to be drawing all that gas that's coming off. It's going to begin up here, and it's going to be travelling along here. It will bubble down here, and then get sucked back up here, along here, bubble down here, get sucked back up here, and out. Which means that whatever is coming off of that candle, the products, are going to go into each of these test tubes in turn. Now, in the first test tube, you've got cobalt chloride paper. Cobalt chloride paper is blue. However, when it becomes wet, when it's in the presence of moisture or water, it will turn pink. So if water is given off, you'll see that blue paper turning pink. What about our second test tube? Well, it contains something called lime water. Lime water is clear and colourless, like here, okay? That's what it looks like naturally on the left-hand side. But when you bubble carbon dioxide through it, it turns cloudy. So if the second test tube turns cloudy, then you know that carbon dioxide is given off. So our two tests are cobalt chloride paper. It turns from blue to pink if in the presence of water. If it stayed blue, then that shows us that there's no water given off. Lime water, it goes from clear and colourless to cloudy, okay? If that happens, you've got carbon dioxide. These tests you need to remember, okay? So you can keep going back and looking at the PowerPoint if you need to remind yourself. But it's worthwhile even Googling or YouTubing products and combustion, and you will see a few demonstrations that look like that on YouTube. Okay, so if you want to have a wee look at that, I know we can't do it in the lab because we're not in the lab, but it's worthwhile having a look at. Okay, tasks for you. First of all, you are now able to complete notes on page 3 of your notes, okay? Filling in the blanks. There is a task where you need to draw and label an experiment. That's the one I've just talked about. Make sure that you do that. In your class notebook, in the quizzes section under your name, you will find extension work for lessons 1 and 2. Do that in the class notebook. And at the end of the lesson, you must complete a check test quiz. I've shown you here where it is. It's in the National 5 channel and it's as a tab at the top. So it's sitting up here. If you click on that, 10 multiple choice questions, give them a go, hit submit. If you don't get them all right, that's fine. I'll give you lots of feedback. They are self-marking as well. Okay, so the feedback will be kind of immediate, so you'll know what you get. Okay guys, give that a go. As always, if you need me, give me a shout. Thanks very much.